Hello everyone. So today we will see the execution of the first program, that is frequency of presence of an element. So already we have discussed the logic in a previous session. So same program we are implementing using a C++ editor. So this program already written on the screen. So we'll take same program and we'll just trace out the program, how the program is going to work. So here we are declared header files. So these are the three header files, basic header files we are declared, and after that we are declared a class frequency. Frequency is the class name because we are writing the program for the frequency. Under class we are declared here private, that is the access specifier. Under private we are declaring a data members here, so int n, em of 100, ele, and frequency, that is freq. So n is nothing but here stand for number of elements. So how many elements required? Here m of 100 is the array declaration. How many elements and which are those elements will be stored in this array. ELE is nothing but the search element, which element you want to search or which element you want to find the frequency or occurrence of that element. And freq is nothing but just a counting, how many times that number is repeated. Under public section, we are declaring three member functions. One is get data function, that is input function. Then find freq, we are returning a short form, that is a process function. And then output function as a display function. And here the class will get closed here. After this, we are writing the member functions outside the class. So the first member function is the input function. So this is the return type, that is void. Frequency is the class name and scope resolution operator. And here input functioning, which we have taken already, get data. So in that we are inputting three input statements. One is for how many elements, then which are those elements, and which element you want to search. So cout, enter the size of the array. So this is the output heading for my input n. So c in n, that is n is the debug number of elements. Cout, enter elements into the array. And we are using a one dimensional array, so single for loop will come here. So for int I equal 0, I less than an I plus plus c in m of I, means it will take those values depending on your n value here. And then enter the search element, that is c in ele. So which element you want to search. So this is about the input function, that is get data function. After that, we are writing the process function here. So void frequency, scope resolution operator, and find freq we are taken as a process function here. At the beginning, frequency 0 means count is 0 here. Now for int I equal 0, I less than an I plus plus. If this condition satisfied, that is I less than condition, I less than n condition satisfied, it will come inside. Inside it will check m of I equal to ele, means your first element will check with the search element. If the condition satisfied, frequency value goes on increasing. If the condition fail, it will come in a for loop here. So come back in a for loop. So in for loop again, I value will increase here. I will check with n. If the condition satisfied, again it will come inside. You check with the if condition. This process goes on continuing till for loop condition gets satisfied. Once the for loop condition fails, then it will come outside the for loop here. And outside the for loop, that is nothing but it will come outside the function here, that is find freq. Then void frequency, that is output function. So if frequency is greater than 0, so if you get a more than 0 answer, then your search is nothing but that time you will get a result, that is frequency of element is present so many times, that is say frequency of EL is a frequency, that is frequency of any element is nothing but that much count here. Or if the condition fails, then it will give that element does not exist here. And then we are returned to main function. In main function, we are taken frequency, that is a class name, here is the object. So using object, we are accessing first member function, that is get data function, that is input function. And then after processing of the input function, it will go for the process function, that is find freq. After find freq, it will access display function here. Now we'll see how the actually program will work by using a tracing. Okay. So first I'll show you the compilation. So compile the file. If no errors are there, so you'll get a message 0 errors. Then you go for execution, that is nothing but run. So run the program. Put the values here. So say here 5. Take any elements, let's say 10, 20. I'll take again 10. Then say 30, and then I'll take 40 here. So 5 numbers are entered. which number you want to search. So 10, because 10 is occurred 2 times here, so answer will come. Frequency of 10 is 2 here, means 10 is repeated 2 times here. We'll see the unsuccess also. So I'll just run the program because there are no errors. So say 5, say any number of elements you can take or any elements you can take. So 20, say 30, say 10, say 40. Then now I'm searching the element, say 35. So by observation only I understood 35 does not exist. So we'll get a result 35 does not exist here. Now we'll just trace the program, how the program is working, okay? So it will start from the main function, okay? Then we jump to that is nothing but object creation, that is frequency of. Then it will go to the input function, see your input. Then it will enter the size of the array. So it will accept value, say 5. Then it will go for input of array elements. So I'll enter here, say 1, say 2, say 3, say 4, say 4, okay? So 5 elements. So that many times it will accept the value. Then it will access, or then it will accept a search value. So now we are searching, say 4. Now it will jump to the process function. So it will process. So it goes on checking the condition that many times. And it will come to the display function. In display function, it will accept the condition and it will give the result. So now see here, you will get output on screen. That is frequency of 4 is 2 here. So 4 is repeated 2 times. So like that program is going to be work here. So this is your first program. So now we will see the second program, that is write a C++ program to insert an element into an array at a given position. So what is this meaning? So suppose now there is a series, say 1, 2, 4, 5. So 1, 2, 4, 5. So we want to insert a 3 at an appropriate position or at a proper place. So 3 will be inserted after 2 and before 4. So that is called a insertion, or that is called insert an element at the given position. So insert an element is nothing but adding a new element to the list here. So see the algorithm. Here A is the array with n, that is number of elements. Yearly, which element you want to be inserted at what position, that is yellow. C is a variable you have taken. So see, this is the algorithm for I equal to n minus 1. So we are going from the downward direction. So I equal to n minus 1 down to yellow C. Means what? I is greater equal to yellow C here. So we are implementing a for loop. So for loop will be int I equal to n minus 1, I greater equal to yellow C, I minus minus. Now a of I plus 1 equal a of I means lower element, okay, that is a of I is the list element index that will be added or that will be inserted at the highest index number here. So see here I plus 1 is there, here I is there. Means if I is here, suppose 1, so 1 plus 1 is what here, 2 here, like that. If suppose I is here 5, then 5 plus 1 becomes 0, 6. It means your lower order element will be shifted to the higher order or higher index number here. So this process goes on continuing till the for loop satisfied here. Once the for loop fails, it will come out, and at that position we are inserting our which element you want to insert. So ALOC equal what? ELE. So ELE will go at that proper position. And here obviously we have inserted one extra element here. So size of the array or size of the, or you can say number of elements are increased. So obviously location is also get increased. So only n is replaced by n plus 1 here. I will trace the program so you'll get idea how exactly it is working. Now I have taken one example here. Suppose we have an array of numbers where the array represents, say, a of 0 to a of 7. We have kept one extra space because we are inserting one extra or new element here. So I have taken 11, 12, 13. Then I have taken 15, 16, 17, and 18. So I want to insert a 14 number at proper position. So I want to insert a 14 after 13 and before 15 here. Okay. So see here, now we have to insert 14 in the array at the proper place so that we get the desired number series. We find that 14 is missing at position 4, that is A of 3. If you count 1, 2, 3, 4, fourth position is nothing but here what? A at A of 3. So this is my fourth position. This is my fourth question. I'll just show you. So I'll take this as my fourth question. So this is my fourth position. So this is my fourth position. Fourth position. So I'm going to insert here element. Okay. So before inserting 14 in the array, we have to move each element of the array, that is A of 3 to A of 6, one position down. Means 15 should go down because we want to make this space empty. So 18 will move, then 17, then 16, then 15 will move. So we'll get here empty position. Okay. Now array before insertion. So this is my array before insertion. So which are the numbers I taken? 11, 12, 13, I have taken 15, 14, no sorry, 16, 17, 18. So these are my array before insertion. Now here total 7 elements are there. So 1, 2, 3, 4, 5, 6, 7 elements. So we have 7 elements. Okay. So we have 7 elements. So n value is what? 7 here. N value is what? 7. So see here n equal to 7. Total number of digits in an array. Now I equal to n minus 1, that is 7 minus 1 equal to 6, because array index number will be starting from 6 here. So n minus 1, that is 7 minus 1 equal to 6. Represent the location of the element to be processed. So from where to process. And location equal to position to insert 3, means we want to insert at this location. Okay, I just shared the location to get idea where to insert. So we want to insert at A of 3, our new element. So now I'll trace the program. So I equal to n minus 1, that is 7 minus 1 equal to 6, down 3. Down 3 means what? I greater than equal to yellow C. So what is I value? 6. 6 is greater than equal to 3. It's a true condition. 6 is greater than 3, true condition. So it will come inside. So inside how we are written? A of I plus 1 equal to A of I, means lower index value will be shifted to the higher index value. So now here I is nothing but what? 6. 6 plus 1 is nothing but A of 6. So at A of 6, which number is there? That will be going to the A of 7. So 18 is my number is there at A of 6. So 18 will go at A of 7. So how it will happen? So here 11, 12, 13, here 15, here 16, here 17, and 18 will be shifted here because A of 7 is occupying what? 18. Now I value also decrease because it's a for loop is there and we are going in a reverse order. So I will decrease here. So I equal to I minus 1, that is 6 minus 1 become 5 for the next iteration. So we'll go to the next iteration. So here I equal to 5 down to 3, that is 5 is greater than yellow 6. So 5 greater than or equal to 3 because yellow 6 is nothing but our location value. So location or position. So 5 is greater than equal to 3, condition satisfied. So A of I plus 1 equal to A of I. Again at A of I, which number is there? That will see that is nothing but A of 5. So 5 plus 1 is nothing but A of 6. So at A of I, which number is there? So we'll just see in the previous iteration. So which value is there? So see here, at A of 5, 17 number is there. Just check it here. A of 5, 17 is there. That will go at A of 6. So here, A of 6 is nothing but what becomes 17. So we'll get here result now. 11, 12, 13, then 15, 16, here 17, and here 18. So now 17 got shifted to the A of 6 position. Now we'll move the next iteration because still for loop is not filled. So I equal to 4 down to 3, that is I greater than or equal to LOC, that is 4 is greater than or equal to 3. Condition satisfied, it will come inside A of I plus 1 equal to A of I. Now I value I got 4, so A of 4. At A of 4 which number is there? Just check it here. So at A of 4 we have this number, 16 number is there, okay? So at A of 4, 16 is there. So that will move to the A of 5. So 16 will be moving to the A of 5. So here 11, 12, 13, then 15, 16, 17, 18. Means 16 is also shifted to the highest order position, that is A of 5. Now I value will again decrease here. So I equal to I minus 1, that is 4 minus 1 becomes 3 for the next iteration. So we'll see now next iteration. So now I equal to 3 down to 3, that is I is greater than or equal to LOC, 3 greater than or equal to 3. Condition satisfied. It will come inside A of I plus 1 equal to A of I. So I value is nothing but 3. So 3 plus 1 equal to A of 3, that is A of 4 equal to. Now at A of 3 which number is it? So see, this is A of 3 value. So this is my A of 3, which number is a 15. So 15 will occupy now A of 4 position, means one position shifted down here. So 11, 12, 13, here 15, 16, 17, 18. Now see here we have got A of 3 position is open. Now I value again decrease, so I equal to I minus 1, that is 3 minus 1 equal to 2 for the next iteration. So now I equal to 2 down 3, 2 greater than or equal to 3. Now for loop condition fails here. If the for loop condition fails, it will come outside the for loop. Outside the for loop, we have written the condition in algorithm A of LOC equal to ELE, means when you will get a appropriate or proper position, we have to insert that element in that position here. So A of LOC equal to ELE. ELE means which element you want to insert. So we want to insert 14. So ELE is what? 14. So A of 3 at which position? A of 3 position. Means in this position we want to insert the element. In this position we want to insert the element. Okay. So at this position we want to insert the element here. So at this A of 3 position we want to insert our element. So A of 3 equal to 14. So element will get inserted here. So 11, 12, 13, 14 is inserted, 15 as it is, 16 as it is, 17 as it is, 18 as it is here. Now see here how many numbers you got. From 11 to 18 we have got now 8 numbers here. Means size of the array is also got increase, means number of elements got increases. So because of that n value is also goes on increasing. So n value was before 7, so 7 plus 1 is equal to becomes 8 here, because we have got 8 values here, 11 to 18. So now here we have inserted a 14 number at proper position here. So this is the inserted element. Okay, just fill this so you'll get idea where we inserted. So we have inserted the element here at proper position, and then the array after insertion is like this. So we have got like this basically. So 11, 12, 13, 14, 15, 16, 17, and 18. So we will get like this way 3, 0. So this is called the insertion algorithm. So we are inserted the element by shifting one element position down here. So this is the header file. Okay, we require class insertion. So we are given class name as insertion. Under private, we are declaring the variable, that is n, number of elements, m of 100, array elements, ELE, which element you want to insert, and p at what position. So p stands for your position. Under public section, we are declaring three member functions. One is the get data function, that is input function, then insert function, that is process function, and display function to display the result. Then outside the class, we are declaring the member function. So return type is void, class name is insertion, and function name is get data. So how many elements? N. Enter the elements. So here it's enter the elements. So I equal to 0, I less than and I plus plus. So C in M of I. So we are inserting the elements here. Then enter the element to be inserted. So which element you want to insert? So enter the element to be inserted. So that element, and enter the position also. At what position you want to insert. So you should know which element and you should know at what position. Then we are checking the condition. If the position is more than your number of elements, if the position is more than number of elements, means say we have 5 numbers and I have given position as a 6 or 7. So that time this condition, what will happen? 6 is greater than, say now position is 7 and n is 5. So 7 is greater than 5. Condition satisfied means p is invalid position. So means what? We cannot take after the n, means beyond the range of elements we cannot take the position here. So we have to take a position between the range only. So only we are given here one constraint here. It is if p is more than n, then it is invalid position. If p is less than n, then only it will go to the else part here. In else part, we return the same logic which are done in our process. So int I equal to n minus 1, I is going to p. So p is nothing but here LOC which are taken in a tracing of the algorithm. So I is going to p, I minus minus m of I plus 1 equal to m of I, m of p equal to ELE. So when this condition satisfied, this statement will goes on executing. Once the follow fails, then it will come outside the follow. Outside the follow, we are in m of p equal to ELE, means at appropriate or proper position, we are inserting the ELE. And once we inserted the ELE, we are increasing the n value here, that is n equal to n plus 1. And see out ELE is successively inserted or successfully inserted. So element is successfully, you can write successfully inserted or successively inserted. Successfully inserted. Then this is my display function. So once the process is completed, we want to display the results. So void insertion display, say out the array after insertion is. So for I equal to 0, I less than and I plus plus, see out m of I. So it will display the result after insertion of the element here. And then void main function, this is my class name, this is my object. So I dot get data function means it will access the input function, that is get data function. I dot insert function, it will access the process function. I dot display function, it will access the display function. So dot is the access operator. Dot is the access operator. Now same program we will implement in C++ editor and we'll see how we will get a result. Now we'll see how this program will work. So already I typed the program. We'll just trace out the program, how the program is going to be run. So these are the header files. Class insertion, private declaration, int n, m of 100, ELE and p. N is the limit number of elements. M is nothing but array. ELE, which element you want to insert, and p is at what position. So first function we are taken as a get data, then second is insert, and third is display. So we have written the body of the function, that is get data. So already I told how to write this. So how many elements you want, which are those elements, that is the array, then which element you want to insert and at what position, that p position. Then if p is greater than n, then it is invalid position. If p is less than n, then only it will go to the else part. Else part we have written the process, okay, and we are just go on moving till we insert the element at the proper position, and then it will display the result here. Now just we'll trace out the program, how the program is actually working. So I'll just run the program and I'll show you first. So compile, no errors. So run the file and put the values. So say 5. So say 1, 2, 4, 5, 6. So 5 elements. So 1, 2, 4, 5, 6. So we are inserting now 3 at proper position. So enter the element to be inserted 3. Okay. So 0 to 5. So 0, 1, 2. So at proper position. So 2. because it is starting from 0, 1, 2. So 0, 1, 2 means third number position. Now see here 1, 2, 3, 4, 5, 6. So 3 successively inserted. So 1, 2, 3, 4, 5, 6. We have got the result. So see here 3 is inserted at proper position. I'll run once again and show you invalid position. So say 5 elements. Say 1, say 2, say 4, say 5, say 6. Now say element I want to insert 3 again, okay? But I'm giving a wrong position, So 0 to 5 is there. I'll take 7 as a position. So 0 to 5 I have to insert, but I'm inputting what? 7 numbers, so which is not a correct position. So see here, I will get a result here. Here 7 is an invalid position. So I'm getting the answer 7 is an invalid position. Now trace the program. So just see how the program will work from where. So it will start from the main function. Here. Then it will go to the insertion. Then we'll accept the value, say 5. Then we'll accept the values. So say 1, say 2, say 4, say, or you can take double digit number. So say 11, say 12, say 14, say 15, say 16. So it is accepting those numbers. So now which element you want to insert, that will accept. So say I want to insert 13. So now at what position? So at what position? So I'll take here 3, not 3, at 2. 0, 1, 2. So 0, 1, 2. 2 is nothing but third number position, okay? Now it will go to the insert function. So obviously position is what? I have taken 2, 2 greater than 5. Condition fail. If condition fail means it will go to the else part. Here it is coming to the else part. In else part it goes on processing till for loop get fails here. So for loop got fail, it will come out now. Okay, now just here it come for the display. Now we'll get a result on the screen. So see here now 11, 12, 13, 14, 15, 16. So we have got this result 11, 12. So 13 is inserted at proper position. So this is about the second program execution.